Hello, this is another video, Texas Instruments 84 on how to graph quadratics with your graphing calculator. Here I've turned the calculator on, and this is the Smart View calculator. If I go to the template to make sure the calculator works, I can enter a simple expression such as 9 times 9, and the calculator says 81. The calculator works, and today, since we're working with graphing again, click the y equals button. And you can see here that I've entered the equation in factored form, and then also down below in standard form. So equation 1, x minus 1 times x minus 5, is the same equation as x squared minus 6x plus 5. And the second equation, negative times x plus 2 times x minus 3, those factors are the same as negative x squared plus x plus 6. In fact, if we go to the graph, you can see that which is the graph button, that both parabolas are graphed because I have them on here, shaded in black in those cells in the column. I want to make sure that those second two equations are the same. What I do is I go to y equals, and I'd go down to that equals sign, and I'd hit enter so that they turn black. Now, when I hit graph again, it will graph the blue and red equations, but then it'll trace right over them the magenta and green equations, as you can see here in this refresh graph, that they're the same equations, just they're collinear. However, when I'm analyzing, I don't want to confuse, even though I have a duplicate of the graph in a different form. I'm going to turn these cells off so that there's no confusion and just work with the equation as I first presented it in factored form as I wrote them. So going back to the graph, we'll now see the graph in blue and red, and as I refresh the screen, it'll be blue and red. The most common equations that are asked are, well, what are the zero values of a quadratic? And then the equations are usually presented in standard or vertex form. Well, we can see here from the first equation that our answer should be 1 and 5 because those are our zero products. And in fact, if we go to the graph, we should see 1 and 5 in the domain give us a 0. So you scroll on the left side, and if we go to 1, we can see for the blue equation that there's a 0 at 1. Then if we scroll down to 5, we can see for the blue graph, there's a 0 at 5. Well, that's because those are the factors that we see on the screen here on the right. For line 2, it's negative x plus 2 times x minus 3. So the first 0 will be the opposite sign, it'll be at negative 2, and the second 0 will be at 3. So if we go scroll on the make sure you go to the scroll bar on the left column, then we can scroll back to negatives. And if we go all the way back to negative 2, we see for this in the second column for the red graph, there's a 0. And then if we scroll forward to 3, we can see that there's another 0 there because of the factors. So that's using the table. Thankfully, the way the equations were written, that's because the zeros were at integer values. If you hit second trace, a menu comes up, and you can actually calculate the 0 using a graphing tool. So when you hit enter, you'll see here for these commands, what you do is for the blue line, if we want to find the 0, it's right near where the drone is now blinking here. So if I move the drone backwards, and click and put up a lower bound column, and then go into the negative space into quadrant 4, click enter, it'll click an upper bound. I know the 0 is trapped because the line crossed from positive y values, here's 2.47, down to negative values. So within that region, since it went from positive to negative, a 0 must be contained in that region. You hit, when it says guess, hit enter, and it says there's an error bound. Why did I do that? All right, let's calculate the 0. I'm on the blue graph and enter. And now we're on the right side, hit enter again. And it finds that there's a 0 at 1, 0. If the calculator doesn't work, just hit clear and try the keys again. Again, one more time, going to the other 0. Well, we know that there's a 0 at 1, and from the factors, we know there's a 0 at 5. So I hit second trace, 2, and it will go to the graph, tracing along the blue line. I know it's at 5, but it was given to me in standard form. Just make sure I'm in quadrant 4 on the left. I'm underneath the x-axis. Hit enter, it'll put up a column. Make sure I'm in quadrant 1. Hit enter, because the 0 is trapped somewhere in between. That's where it went from negative to positive on the graph. The blue line, hit enter again, and it will tell you along the perimeter of the window, the function, that there's a 0 at 5, 0. If you want to switch to the other graph, you can click up or down. So if we switch to the red graph, for example, and we want to find the 0 that's at -2, here I have to move the drone all the way back so that since it's going from negative to positive, make sure I'm in quadrant 3, hit enter, a flag will come up. Then make sure I'm in quadrant 2 because it's going from negative to positive in Y value. Hit enter again, and it says that the 0 on the red graph is at -2, which was the first factor. So that is how you find the 0 values using your graphing calculator when graphing quadratics.